Hello guys. Today I'm going to talk about the nomenclature of organic compound. Especially I'll be focusing on the alkane. When we talk about the nomenclature, the IUPAC naming of alkane, you guys needs to understand what are prefix, word root, primary suffix, and secondary suffix. So the alkane, if contain only one carbon atom, we give the word root as the meth. If the compound consists of a two carbon atom, we give eth as the word root, three carbon containing prop, four carbon is a bute, pent for 5, hex for 6, hept for 7, oct for 8, non for 9, and then dic for 10. In this compound, as you can see here, the carbon-carbon bond is a single. If the compound consists of a carbon-carbon bond single, we give the primary suffix as an ane. So that's what is the ane comes. So whenever this meth and ane combines together, then we'll end up getting methane. That means carbon has only, the compound has only one carbon, right? And literally it does have a single bond. There cannot be double bond in the one carbon containing molecule. Now in the case of the ethane, you have a eth means a two carbon and the ane means a single bond. So that means the molecule is a ethane, so CS3 and CS3. In the case of a propane, there's a three carbon atom and there is a single bond between the carbon-carbon. So that's why we call it prop and ane. And there we go, CS3, CS2, and CS3. So when you take a look at these molecules, remember that the valency of the carbon is 4. So each carbon must bear 4 bonds. Here carbon bear 4 bonds and are bonded to 4 hydrogen. Here in this case carbon is bonded to the 3 hydrogen in the left side and another one, fourth bond is between the carbon. So likewise the carbon in the right hand side is 3 hydrogen and 1 carbon-carbon bond. If you consider the propane, the same thing, left and right carbon has a 3 hydrogen and 1 extra bond between the carbon and carbon. How about in the case of the middle carbon atom? And this carbon atom in the middle, you have 2 bonds with the terminal carbon atoms. Likewise, there are 2 hydrogen in the middle, so there's a 4 valency of the 4 carbon is satisfied. Okay. In each of these cases, again, butane has a 4 carbon single bond between the carbon atoms. Pentane has the same thing, hexane, heptane, octane, nonane, and decane. In each of these cases, you have a word root and primary suffix making the name of the molecules. As you can see in the right hand side, I have depicted the molecular formula of the compound in the form of carbon and hydrogen. This is the condensed form of the loose structure, so that's why we call it that's why these structures are called a partially condensed structure. This can be transformed into the bond line structure. So if we convert that into the bond line structure, it looks like this. So the methane has only one carbon, so there's no way that you can just represent with a line only. But in the case of the ethane, since there are 2 carbon atoms, so these 2 carbon atoms can be depicted simply by a line. Whereas in the case of the propane, there's 3 carbon atoms. So it's 1, 2, 3 carbon atoms, and each one of them are bonded together by a single bond. So that's why we have a propane. The structure represents the propane. And remember one thing, each terminal end of the molecules represents CS3, where the one in the middle is the CS2 in each of these cases. As for example here, CS3, CS2, 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 and CS3. So the terminals are CS3, the middle ones are CS2, as long as there is a carbon-carbon single bond. And we always remember that we always try to bend the bond as we are mimicking that it is following like a 109.5 degree of like a bond angle, because remember that each of these carbon atom undergoes sp3 hybridization, and carbon with the sp3 hybridization has a bond angle of 109.5. All right, let's talk about the prefix now. But before you understand the prefix, you need to understand what is the structural isomers. The structural isomers are compounds having the same molecular formula, but their spatial arrangement of a group of atoms present within the molecule in a different way. Or I can say that it is originated by the breaking of the bond and reattaching into the different part. As for example, in between these two compounds, you see that this is the butane, and this is also butane in terms of a number of carbon. But you can see that the second structure is originated once it is the CS3 bond is broken and then attached into the internal carbon atom. If you consider methane, ethane, and propane, they do not have a structural isomers, whereas starting from carbon number 4, the compound does have structural isomers. So how are we going to name these molecules, right? Because these two molecules are different, because this is the N-butane, this is the 2-methyl-propane. Their chemical structure might be same, but their physical properties are clearly different. In this compound, you have a 4-carbon atom, so the name of this compound, by default, there's a word root is a but, and then carbon-carbon single bond, so it's a butane. How about in this case? In this case, you can start numbering either from left to right, right to left, top to the bottom. It does not matter. But according to the IUPAC naming rule, we have to always choose the longest carbon chain. But luckily, in this case, whichever way you go is always number 3. So 1, 2, 3. So that's why you can arrange these two molecules in this fashion, right? In the bond line structure, which is easier. So in this case, what's happening is that in the second carbon atom, you have a CS3. So where the CS3 is coming from? If you have a methane and if you take out one hydrogen from here, so methane will lose the hydrogen and becomes what? Methyl. So that's methane. The CS3 is originated from methane. That's why it is called the methyl. So prefix will now becomes what? Methyl. So that the name of this compound will be 2-methyl-propane, because the locant, the substituent's locant is the second carbon atom. So you have a CS3, the second, so that's why it is called 2-methyl-propane. So let's take a look at another molecule, which is the pentane molecules. In the pentane molecules, you can again, this is the condensed structure, partially condensed structure, but as this is the bond line structure. So in this bond line, let's take a look at the bond line structure, which is easier. So you have 5 carbon atoms, 1, 2, 3, 4, 5, and it's a straight chain. So pent is the longest carbon chain, single carbon single bond. That's why it is the pentane. Whereas in this molecule, you can see that if this one of the CS3 is broken here and then attached into the second carbon, you'll end up getting this molecule. Or if you break the one in the left hand side and then you stick into the 4th carbon, you'll end up getting this molecule. So these two molecules literally are the same. Why? Because if you start numbering the longest carbon chain, you'll have a 1, 2, 3, 4, 1, 2, 3, 4. Both these structures are same number of the longest carbon chain in terms of, whereas in terms of the CS3 substituent, here the CS3, which is CS3 here, CS3 here. Now the locant is important, so it's the second position in both of these cases. So according to the IUPAC system, we have to choose that end of the carbon, that end of the longest carbon chain, where the substituent is the nearest, right? This is the second position. If you start counting from left to right, 1, 2, 3, 4. How about if you start counting from the right to left? That'll be 1, 2. This will be a third position. So this is not the acceptable way of giving a name to the molecule based on the IUPAC rule. So the name of this compound will be 2-methyl-butane. Same thing is true here. The longest carbon chain is a 4. The methyl group is in the second position, so that's why it is a 1, 2, 3, 4, 2-methyl-butane. Let's take a look at the last compound. In this compound, again, this is originate. How is it originate? Now, from this compound, if you break one of the CS3 here, and this stick it into the second carbon, you'll end up getting this structure. In this structure, you have two CS3s in the second carbon. The longest carbon chain you can consider as a horizontal, or it doesn't matter whichever you go, from top to bottom, left to top, bottom to right, it doesn't matter whichever we go. It's a symmetrical molecule, so it's easy now. So the longest carbon chain is 1, 2, 3. So 1, 2, 3. How about in the second position? Second position has a 2-methyl group, right? So because remember that CS3s are originated from CS4, right? So methane becomes methyl. So two CS3s are here in the second position. So you need to define each one of them. Mono CS3, di CS3 in the second position. So 2,2-dimethyl. Longest carbon chain is a prop, and single carbon-carbon is a single bond within the molecule. Overall, it's ane, so that's why 2,2-dimethyl propane. Let's take a look at the 6-carbon containing molecule. In this molecule, if you have a linear molecule, it's easy, hex and then ane, hexane. So now if you break the 6th carbon and attach it to the second, you'll end up getting this molecule. Or if you break the first carbon and it has to the 5th carbon, you'll end up getting this molecule. But both of these molecules are again structurally same. Why? Because if you consider the methyl locant CS3, so both of these in the second position, 1, 2, 3, 4, 5. Longest carbon chain is a 5, 1, 2, 3, 4, 5, and CS3 is in the second position in both of these cases. So that would be 2-methyl, pent is the 5 carbon, and carbon-carbon single bond in both of them, so 2-methyl pentane. Let's take a look at this molecule here. This can be originated if you break this bond in the left-hand side and attach it right into the 3rd carbon. You'll end up getting this molecule. So this molecule, again, you can write the structure into the bond line structure. You'll end up getting this molecule at the bottom. You have a longest carbon chain, 1, 2, 3, 4 carbon atom. Second position and third position is the methyl group. So it doesn't matter whether you start numbering from left to right or right to left, you'll basically end up getting the same structure. So here, the word root will be but, 1, 2, 3, 4, but. Overall, within the compound, there's only single bond. A single bond is present between the carbon and carbon. So that is the ane, butane. So in the second and third position, there is a methyl group, so 2 methyl groups, so 2,3-dimethyl butane. How about the last structure? In the last structure, if you again break the 3rd carbon methyl group and attach it to the second, you'll end up getting this structure. In this structure, you have to number now, first of all. You have a 4 carbon is the longest carbon, 1, 2, 3, 4. You can start counting from the top to the right, bottom to the right. It doesn't matter. It's the same length of carbon chain. So the carbon chain, longest carbon chain is a 4, so it's a but. Within the compound, there are only single bonds between the carbon and carbon, so that's the ane, so butane. And in the second position, the second locant, the 2 methyl groups locant is in the second position, so 2,2-dimethyl butane. That would be the IUPAC name of these molecules. So all these compounds, like 1, 2, 3, and 4, all these are considered as the structural isomers or the constitutional isomers, and this type of phenomenon is called the structural isomerism and the constitutional isomerism.